Today we will learn fineness modulus and grain size distribution of fine aggregate. Aim of the experiment is to determine fineness modulus and grain size distribution of fine aggregate. Apparatus required: Indian standard test strips 4.75 mm, 2.36 mm, 1.18 mm, 600 micron, 300 micron, 150 micron, weighing balance, sieve shaker, trays, drying oven. Materials required: fine aggregate. Theory and scope: the size of the fine aggregate is limited to maximum of 4.75 mm gauge, beyond which it is known as coarse aggregate. Sand as fine aggregate for concrete or mortar is required to be well graded on the principle that the smaller particles shall fill the void between larger particles, leaving minimum voids that are supposed to be filled up by the cement particle in the resulting mass. For normal structural purpose, the grading shall be within the limits specified in IS 3831970. Standard grading zones or limit of percentages passing different shifts are specified for proper grading of sand into grading zones 1, 2, 3, 4 as shown in the following table. Table 1 is representing grading limits of fine aggregate IS 3831970. In order to ensure the presence of all sizes of particles, the property of aggregate called fineness modulus is defined. The fineness modulus represents the mass average size of the sieve on which the material is retained. The sieve being counted from the finest, the following limits on fineness modulus may be taken as guidance. Procedure: take 1 kg of fine aggregate from the laboratory sample. Care shall be taken to ensure that the sieves are clean before use. Next, carry out sieving by using sieve shaker. Shake each in order 4.75 mm, 2.36 mm, 1.18 mm, 600 micron, 300 micron, 150 micron over a clean tray for a period 2 minutes shaking. Next, the shaking shall be done with a varied motion backward and forward, left to right, circular, clockwise and anti-clockwise, and with frequent jarring so that the material is kept moving over the sieve surface in frequently changing directions. Next, the material shall not be forced through the sieve by hand pressure. Lumps of fine material, if present, may be broken by gentle pressure with fingers against the side of the sieve. Next, find the mass of aggregate retained on each sieve taken in order. This figure shows you Indian standard sieves. Observations and calculations. Draw the table. Fineness modulus of fine aggregate is equal to sum of cumulative percentage retained on sieves divided by 100. Result: 1. Fineness modulus of a given sample of fine aggregate is dash that indicate coarse sand, medium sand, fine sand. 2. The given sample of fine aggregate belongs to grading zones 1 or 2 or 3 or 4. 3. Particle size distribution or grading curve is plotted between the cumulative percentage finer or passing versus particle size or sieve size on a semi-logarithmic scale. Conclusion: the experiment has an important bearing on the concrete mix. From the result of sieve analysis, one is able to proportion the fine and coarse aggregate in order to get combined mix of required gradation. Precautions: 1. Material is not to be forced through the sieve by hand pressure, but lightly brushing with a soft brush on the underside of the sieve may be used to clear the sieve openings. 2. There should be no loss of material or fines during the process of weighing, sieving or transferring, and total weight on the sieves and bottom pans should tally with the sample weight taken. Reference: 1. IS 383 specification for coarse and fine aggregate from natural source for concrete. 2. IS 2386 part 1 method of test for aggregates for concrete, particle size and shape.